Hi and welcome back. So in this problem, or in this video, we're going to do problem number 19 out of the first signals recitation. And the problem is this. We're given a function, x of t, that is equal to 4 cosine of 5 pi t minus pi over 5. Let me just make sure that that's right. 5 pi t minus pi over 5. Yeah, that's right. Okay. So what we want to do is we want to take this and represent this as a sum of complex exponentials. So that's the problem. Take this function, represent it as a sum of complex exponentials. So now I guess I'm just going to start doing the problem. So remember that what we're doing here, when I say we want to represent this as a sum of complex exponentials, what I want is I want something of the form a times e to the j omega t plus a conjugate e to the minus j omega t. And I'll show you where this comes from. If you remember, and I told you we were going to be using this a lot, Euler's formula, which was m e to the j theta, or our version of Euler's formula, which just has the magnitude in front of the e to the j theta, is equal to m times the cosine of theta plus j times the sine of theta. If I took this and I took the complex conjugate of this whole expression, if I took this expression right here and I did the complex conjugate of both sides, and it would still be completely equivalent. If I take the complex conjugate of this side, so let me just do that, m e to the minus j theta. So keep in mind, all I'm doing is I just multiply that theta by a negative sign. That gives me my complex conjugate. So now I've taken the complex conjugate of the left-hand side, and I want to take the complex conjugate of this right-hand side as well. All I need to do is flip that sign. I get m times the cosine of theta minus j times the sine of theta. Put that parentheses there. So now I've got my m e to the j theta and its rectangular form. I've also got my m e to the minus j theta and its rectangular form. And what I'm going to do now is I'm going to add these two expressions together. And so now if I add these together, I get m e to the j theta plus m e to the minus j theta, and that's going to be equal to, I've got plus j sine theta and minus j sine theta, so those two cancel out, and I'm left with 2m cosine of theta. So now I can say, and first off, let me just go ahead, actually let me go ahead and I'm going to remove the m's. But you can hopefully see the m's on both sides cancel out. I probably should have started this without the magnitude in the equation, and I even forgot it on the sine side, but hopefully you can see it still would have canceled out there. I could have started this without the magnitude. I'd be getting the same exact answer right here. So what I'm going to do now, I'm just going to cancel out my magnitude. My magnitudes cancel here. And I'm left with e to the j theta plus e to the minus j theta is equal to 2 cosine theta. So now the last thing I'm going to do is I'm going to divide both sides by 2, and I get 1/2 e to the j theta plus 1/2 e to the minus j theta is equal to my cosine. And now the very last thing, and probably I should have just left my magnitude in there, the very last thing I'm going to do is I'm going to put my magnitude, or not my amplitude of the cosine back in. And actually, let me not write m. I'm going to write this as k. I'm going to write this as the amplitude of my cosine, which is k cosine theta. So now I just have to multiply each of these terms by a k. So I get k over 2 e to the j theta plus k over 2 e to the minus j theta. So now I've got a way here of taking a cosine And keep in mind, theta, I could stick anything in for theta. I could stick this whole thing in for theta right here. I've got a way of representing a cosine, even if it has, an omega and a phase shift and everything, and representing it as a sum of complex exponentials like I have here. So let me go ahead and what I'm going to do is I'm going to do this just completely generally. I'm going to say if I had k cosine of omega t plus a phase angle, if I represented that in this way, I just keep this same expression, but everywhere I had a theta, I'm just going to say omega t plus theta. So now, and actually, you know what? I'm not going to use theta. I'm going to use phi. So now, everywhere I had a theta, I'm going to use omega t plus phi. So I'm going to get k over 2 e to the j times omega t plus phi plus k over 2 e to the minus j omega t plus phi. And so now that I've got this, let me just go ahead and I'm going to break this up a little bit more. I can say that this is equal to k over 2 e to the j omega t plus j phi plus, and that's all the exponent there, plus k over 2, that's a k over 2 e to the minus j omega t minus j phi, that's the exponent there. And now the last step I'm going to do, if I'm adding stuff in my exponent here, I can break that up like this, right? I can say k over 2 e to the j omega t times e to the j phi plus k over 2 e to the minus j omega t times e to the minus j phi. So now I've got this broken up, and hopefully that's not a big leap for you to see that we can do that. Whenever I do this, I always kind of have to think to myself, okay, if I had x squared plus x to the fifth, and not x squared plus x to the fifth, x squared times x to the fifth, that's like I had 2 x's here, and then 5 x's here. So that's 1, 2, 3, 4, 5, 6, 7. That's 7 x's that I'm multiplying together, so that's x to the 7. Same exact thing as if I just added 2 and 5, and the 2 plus 5 became my exponent. So if I had it like this, I can break that up like this. I can multiply, instead of adding or subtracting up here, I can just multiply another e raised to that exponent. So hopefully that makes sense to you. And then, excuse me, sorry. The last thing I'm going to do is I'm just going to switch the places of my phi and my j omega t. So I'm going to get k over 2 e to the j phi e to the j omega t plus k over 2 e to the minus j phi e to the minus j omega t. And so now what we've got, if you remember from what I said we were trying to do at the beginning of this problem, we've got something that's exactly in the form that we want. A e to the j omega t plus a conjugate e to the minus j omega t. And that's what we've got down here. I've got, this is my a, and this is my a conjugate. Everything is the same between these two numbers. I've just multiplied my phase up here by -1. And then I've got e to the j omega t here, e to the minus j omega t here. So now, if I want to represent this number, I'm going to rewrite this down here. 4 cosine 5 pi t minus pi over 5. So if you remember from the beginning, our x of t was equal to 4 cosine of 5 pi t minus pi over 5. That's 5. I can see really quickly that my omega is equal to 5 pi. My k is equal to 4. That's that 4 right there. And my phi, for my phase is equal to minus pi over 5. So now, really simply, by going through, after I went through all of that algebra, I can just go ahead and rewrite x of t as my sum of complex exponentials. K over 2, so 4 over 2, that would be 2. Sorry, let me draw a better 2. 2 times e to the j phase. So that would be e to the minus pi, or minus j pi over 5, times e to the j omega t, omega is 5 pi, e to the j 5 pi t, plus k over 2 again, which is 2, so 4 divided by 2 is 2, e to the minus j phase, so minus j phase, minus j times minus pi over 5 is going to give me positive j pi over 5, positive j times pi over 5, and then e to the minus j omega t, e to the minus j 5 pi t. And that's pretty much it. We're done. We've got our sum of complex exponentials. One thing to kind of just notice here is if you were looking for a, if you were looking for your term a here, that I say where we have a and then a conjugate, our a term here is 2e to the minus j pi over 5. So that gives you kind of like the magnitude information and the phase information that you're looking for. And if you figure out what that a is, all you need is a conjugate on the other side, which is easy to do. You just multiply it by -1. So anyway, that's it. Hopefully you found this useful, and in the next video, I think we're just going to do a few more examples like this. And I'm not going to go through all of the algebra. If you need to see the algebra again, rewatch this video so you can see where this form exactly comes from. Anyway, thanks for watching, and I'll see you in a future video. And by the way, this is the answer down here. Thanks for watching.